Welcome to another Silicon Labs podcast. This episode shares a Q&A session discussing the latest digital audio bridge solution from Silicon Labs. It's the CP2615. Parker Dorris is the product manager for the interface solutions at Silicon Labs. These solutions include the USB to UART, the USB to SPI, and the USB to I2S, which is the topic of today's conversation. Parker, I'm glad you could take time today to answer a few questions that a lot of people may have about these parts and about this latest solution that you released. It's really a USB solution for digital audio.
Yeah, Kyle, thanks for having me on.
Well, before I get into a couple specific questions I found when I reviewed the material that you provided people, can you give us just a quick elevator pitch on what exactly the CP2615 offers customers?
Sure, yeah. The CP2615 is an interface device that bridges USB audio class and HID with I2S and I2C buses that are connected to audio codecs. So this is a product that is meant for USB audio applications on Android, Windows, Linux, and Mac, including headphones, headsets, and other USB-enabled audio accessories. The 2615 speeds time to market because our customers don't have to become a USB audio expert to release a product. We sort of give them this turnkey solution that provides this bridge so they can concentrate on making their products great. And we offer, with the 2615, flexibility because if a customer wants to try to buy a codec that has a USB interface on chip, their choices are extremely limited. But if they use our bridge device, it opens up a world of options for cost-effective codecs that they can use in their products. And finally, with the 2615, we're offering ways for the customer to differentiate their audio accessories through a number of features with GPIO control and a sophisticated interface between the 2615 and the USB host that enables host applications to communicate with the embedded side through UART and I2C interfaces.
All right. Well, as I said, I looked through the data sheets, and one thing that I noticed is that the CP2615 mentions that it has an additional input for user audio control. And would this be the input that allows, a play or a pause or a volume control that I've seen on my headsets or other devices? And then one more thing, I did notice that it mentioned that it allows for gesture detection, and I wasn't clear about that. If you could maybe talk about those two things.
Sure. Okay. So one of the USB device classes, the HID class, supports a number of media control buttons. These are the buttons that will control play, pause, scan forward, back, stop, mute, really kind of standard interface controls for a lot of audio applications. And the 2615 can translate the input pins that are on the device, the state of those pins, to those media control button events. So an end customer can add a mechanical button and map it, route it to one of these inputs and configure the 2615 to monitor that input. And when a button press is detected, it can report a play pause button event to the host processor. And this is something that we just kind of give off the shelf as a turnkey solution of the 2615. But if a customer is trying to roll their own with their own embedded MCU, they're going to have to learn all the intricacies of the HID class and figure out how to properly report all of these button events. So it's something that absolutely speeds time to market for our customers. We also, with the 2615, support gesture detection. Gestures in this context are the kinds of things you see in audio accessories where you can press a button for a longer period of time and have a special kind of response from the host device that's playing audio, or you can have a double tap or a triple tap on a button. This is really useful in older versions of let's say Android, because until recently gesture detection was not natively supported in Android devices. In newer Android versions, gesture detection is natively supported. So this feature is becoming a legacy feature over time because fortunately that responsibility is being offloaded to the host.
Okay, but it's definitely, like you said, for those that don't have that in their device, if they want to rely on the CP2615, they get that feature. So that's good. And I definitely use that when I'm using my Siri feature. Or
Absolutely, yeah.
So this is a more technical question that I'm really unfamiliar with, but I did notice that the device is classified as a USB Class 1 audio device, and that I think the sample rates are either 48 kilohertz or 44.1 kilohertz. So I was just wondering how does that impact the designer, or do they look at that when they're considering audio playback or things like that?
Sure. Well, so first of all, it's kind of a space race when it comes to sample rates and bit rates with audio products these days. There's a certain point after which the human ear can't really tell the difference. The 44.1 kilohertz sample rate, that's what CDs used, for decades. And, for the average consumer, that's fine. The 2615 is geared toward this broad customer base that finds that level of audio acceptable, which is really most people. We're not really targeting this studio level microphones or headsets, or this is not for the audiophile set. The 2615 is designed to create a fast time to market headset that might go in the box of a phone, or an audio accessory that is really for the masses. The difference between USB audio class 1 and audio class 2 is mainly one of bandwidth. So if you really needed to have tons of audio channels with 24-bit plus playback, then the 2615 isn't for you. But if you look at the standard driver in Android is a 48 kilohertz sample rate 16-bit driver. We're not. This is kind of a point where we've already reached a level of audio fidelity that works fine for most customers. The truth is, if you have an audio file that's of a higher sample rate than 48 kilohertz, in most cases, Android, or if you're using a PC or Mac, it's going to transcode that sample rate to 48 kilohertz or 44.1 kilohertz. And one other note about this is that a lot of codecs only support these sample rates as well. So really, this is just geared toward hitting the biggest chunk of the market that's out there, and this is giving customers kind of the most flexible solution within that context.
Perfect. Okay, that's good, because like I said, I didn't know much about it. I just, anytime somebody sees a class 1 or class 2, they probably wonder what's the difference. So that's a very good explanation. The last thing is, and probably should have asked you this question first, Parker, but throughout the website and the data sheets and the user's guides, I keep seeing where you mentioned that there's no external components and there's a lot of integration. Can you talk about it? Is it the crystal and the power regulator? Are there more things that a customer doesn't realize is being integrated into the CP2615 that's going to save them cost, or really reduce the size of their board? What's being integrated?
Yeah, that's a good question. I'd like to try to expand on it a little bit. First of all, let's address these hardware points of integration that you mentioned. Yeah, the 2615, like all of our USB-enabled MCUs that we offer at Silicon Labs, supports crystal-less operation, so we can meet USB specifications without any kind of external crystal. Of course, that reduces BOM costs. We also have an on-chip regulator, which further reduces BOM costs. In a lot of these applications, of course, you're powering a codec on this board as well, right? And if you don't have some way to, you're either going to need an external regulator that's taking the V-bus signal from the USB host and dialing down to 3.3 volts and powering the codec through that, or you could use the 2615 VDD pin. We can source enough current, more than enough current to power a codec and other components on the embedded side. And so that's one way that we reduce the BOM cost and design time that's needed to get a product to market. But I said I wanted to expand on it because we offer a level of integration with the 2615 that helps customers in ways that don't really affect the BOM, but that affect the development cycle in a way that could end up being substantial, especially for maybe smaller customers, tier 3, tier 4 customers that don't necessarily have a bunch of resources to throw at these different disciplines that are required to become an expert in before you can release a product to market. And I've mentioned some of these throughout this discussion already, but we offer, for instance, an I2C interface on the 2615 that can be connected to a number of other components on the embedded side. So we provide a bridge from an Android phone into whatever components the end product has, so that without any kind of coding on the embedded side, we're providing these customers with a way to communicate with all the other components, maybe sensors, maybe other MCUs on their end product. We also have a UART interface that functions similarly. So we give customers these little bits and pieces. Some of them may not be used for a particular application, but it's important to know that they're there, because we're trying to integrate features that might otherwise be found on an embedded MCU that would sit next to the 2615. We're trying to integrate features that otherwise, for instance, you might need an Android developer with a pretty high level of expertise on how you communicate at a low level across USB. We're giving people those pieces of their puzzle off the shelf. There's an incremental improvement that we add from hardware development to firmware development to software development that ends up yielding a really fast time to market solution.
Okay, yeah. At the very end, you were saying that they might not know what they could use it for, but they didn't expect it. And once they look further into the part and they find that I2C or the UART or the different interfaces, they might surprise themselves in some of the original ideas they come up with. So you never know until you get it for free, and then you find ways to use it. So that's great.
And one point about that, we do have, of course, an evaluation kit for the 2615, and it interfaces well with the Simplicity Studio Express Configurator tool. So all these features that we're talking about can be exercised through that tool. And you can configure a 2615 on this board and then plug it right into an Android phone and see how it performs. So it's a pretty low barrier to entry in terms of starting development with the 2615.
What's the name of that kit?
It's a CP2615-EK-2.
Okay. That's people have to take a look at that. All right. Well, that's a great resource, getting the starter kit. Is there a website or a short URL that people can go to find out more? There may be other questions people have. Where would you suggest they go?
Yeah, absolutely. The place to start is www.scilabs.com/digital-audio.
Perfect. All right. Well, thanks, Parker. Again, it's great to have you spend time with us, and maybe in the future you'll have some other interface products that you can take time to give us some information on.
I'm looking forward to it.
All right. Thanks, Parker.